Hi people, this is Tanmay and welcome to our your ML students YouTube channel. So from today's video, we'll be starting another playlist on AWS SageMaker where we'll show you what is SageMaker is and how can you train and deploy different kind of machine learning and deep learning model with the end-to-end solution. So today we'll start with a very basic thing that how can we train a machine learning model using a inbuilt linear regression algorithm which is provided by Amazon. So let's get started. So before deep dive into it, I'd like to mention one thing is that whoever is not having any AWS account, I told you in the introduction video we'll got to cover, and yeah, we'll be covering you. So we'll try to give some temporary AWS account access where you guys can implement the same what I'll be implementing in today's video, and it will be for a very short time because we can't afford, because it will charge a bit while do this stuff. That is why it's a bit hard for us to do the implementation because we have just started a YouTube channel. So right now we do not have any much revenue to give you the access for a longer time. So we'll try to give you a short access where you can just implement what you have done just to get a hands-on idea what I'll be showing in front of you. So based on the output of the video, based on the likes or based on the comments, we'll try to provide that thing. Once we get it, we'll automatically contact with you and we'll tell you how to contact with us. So let's start today's video. So first of all, let me just cut whatever I have opened. So I'd like to showcase you from the beginning stage. So first of all, here you can see my AWS management console. I've logged in here. And now I need to search here पे Amazon SageMaker. You can see already is here in my UI, but if you have opened for the first time, you may not be able to see it. I need to search Amazon SageMaker. I need to right click and open link in a new tab. So you can see it's opening. Right now you can see one part called domain, right? So here before starting anything, in your case you should not have any domain if you are using your own AWS account, or if you have not worked with Amazon SageMaker before, then you may not have it. So first of all, what you need to do, you need to create a domain. So what you need to do, in my case I have already a domain created for me. For example, if you want to do that, you need to click on create domain. Then you need to set up for single user for the quick setup. If you are working for your company, you can go with the organization, they have more options available for it. And keep in mind it will charge a lot also for that. So as of now I created using this quick setup only a long time back. So once you click on setup, things will work for you, but as of now I'm not creating anything because I have it already. Now let me again cut this one. Let me go back to the same page again. Okay. Okay, so now it is created. Now once your domain will be created, you need to click on the domain. In my case it's dev storage personal. So you can see their user profiles. The lot of user profile you can add here. If you want to go to add user, click on add user. You can give a name. By default they used to give a name, but you can give your own name also, and you have to provide the execution role. So where whatever SageMaker instance will be running behind the scenes, this execution role will be working on. And what this execution role does, it will give AWS SageMaker all the necessary access which require AWS SageMaker to train and deploy a machine learning model. So behind the scene, it will automatically attach this execution role. So once you create the user profile, it will be attached automatically. Even inside the code also, I will show you how to do that. So once you click on next, you can get those steps. As of now, I'm not showing because already have the user also. It's not hard, buddy. You just click on next, it will be created automatically. So you do not need to worry about it. So once that is created, it will take some time to create it. So you need to click on this refresh thing until and unless it will be created properly. So once that is done, you can get the name. In my case, default name I kept. So this is what I have as of now. So what I need to do, I need to go here, launch, and I need to click on studio. So once I click on studio, it will be redirecting me to the application. So it will take some time to do that. So that is one thing. Now I need to discuss it about some documentation thing. Like you need to go to this Boto 3 documentation. Both the documentation, let's say SageMaker. Yeah. So go to the documentation SageMaker. So once you click on this documentation, you can see Boto 3 documentation for SageMaker, right? So this is the documentation provided by AWS. So this library we need to use while connecting with any AWS services from SageMaker. Even if you want to implement in local also, if you want to connect with AWS or require AWS CLI, I will discuss what AWS CLI, as well as you require Boto 3 to do that. But as of now, we'll be working on SageMaker, so we'll go with SageMaker only. Later, I'll show you how to connect with local and other steps. But this Boto 3 will be your best friend while implementing with Amazon SageMaker. So let's wait for some time. Once this application will be created, we will proceed with it. So you can see that the UI is coming. This is loading. It will take some time to do that. So let it take some time. It will be loaded automatically. Yeah. So we have the UI. You can see it. And already I have uploaded my CSV file on which I will be working on. So how you can upload it? You need to click on here, upload files, and then you need to select whatever you want to select, and just click on upload. It will upload your CSV file. So these are students code data on which we will be working on. So today we'll build one simple linear regression model where input column will be hours and output column will be scores. I am not going to show any data manipulation, any feature engineering or anything. I'll just show you how can you train using SageMaker inbuilt algorithm. How are the steps, how you need to send it, and how you'll get the output, and how can you deploy it also. So that I'll show you today. So now, first of all, what you need to do, you need to create a Jupyter notebook. You can see it's a kind of a Jupyter notebook only. It's a automated system provided by AWS where you can get any CPU GPU support. Let it be from low end CPU till the high end GPU. You do not need to install anything in your local system. You will get everything from here in cloud. You just need to pay for it. So I will show you how to select those GPUs and all. So first of all, let me create a notebook. I need to right click here and then create on new notebook. So once I click on new notebook, you can see some things came up. First of all, the image. So behind the scenes, some Docker container will be running, and this container will be containing Python 3.0 in which you can see official Python 3.10 image. If you want to take 2.0, you will get official 3.8 image, and you can see SageMaker distribution for CPU for GPU, and for Anaconda edition you can see 2 Spark Analytics 1.0, 2.0, base Python 3.0. Even if you want to use TensorFlow CPU with the Python version 3.9, you can get it. Same for GPU, simple CPU optimized, simple GPU optimized, and lot of stuffs are there. Based on your requirement, you can use any one of them. It is having for PyTorch also, for other stuffs also. So according to your requirement, you can choose any one of them, but keep in mind it will charge accordingly. So before choosing anything, you need to make sure you know how much it may cost. As of now, I'm going with 3.0 because I'm using official Python 3.10 image. It's a kernel, you know, it's Python 3, and this is the instance type. So the bigger the instance type, bigger the storage you get, bigger CPU memory you get. As of now, this is the bare minimum thing, ml.t3.medium, which is kind of giving you general purpose instance. It is called. A lot of instance types are there. I will discuss about it in our cloud computing playlist. But as of now, you can see this is a general purpose instance which will be launching faster. You can see first launch, so it won't take much time to launch it. So it will give you a 2 vCPU plus 4 gigabyte space. So if you want to need more, you can choose large 8 gigabyte, or maybe you can choose C5 large. It's computer optimized, so it will be do computation very faster manner. Now based on the requirement, based on the acceleration compute or general purpose, they are having their own instance types. So if you want a higher instance type, you can choose it from here: T3 2x large, M5x large. Based on your requirement, you can get, based on your storage size, based on your requirement, you get everything. You will get GPU support from here. So again, it will charge accordingly. So before choosing anything, it's a caution thing to see the pricing before choosing anything. As of now, for me, I do not want to pay too much, so I'll go with this T3.medium. And this startup script, as of now we have no script. What does it mean by startup script? When your notebook will be started, right? So before that, one script will automatically run behind the scene. For example, before running this notebook, you want to install any dependencies, for example TensorFlow, PyTorch, pandas, numpy. You behind the scene you have to write a script which will do it for you automatically. It will do the installation for you in this server only. So this is what startup means. But as of now, we do not need to do anything. Whatever we have, we by default will keep it, and we click on select button. So it will take some time to start the notebook kernel. So once that is started, we'll be implementing our solution. So let's start the implementing thing first, because let it create, because right now I need to write a lot of code to do that. So first of all, let's import some necessary libraries, because importing necessary libraries, importing any necessary libraries, that is import pandas as pd, import numpy snp, import I am not going to do any visualization, but still I am keeping it, as I might use it, I don't know, but I don't want to use it. Let's not use matplotlib because I'm not using it. So apart from that, let me show import boto 3, which I already mentioned I will be using it. And as of now, let's skip till now this point only. Let it later, if I require any library, I will install accordingly. So now let's read the csv file also. Let's write the code for that. Read the csv file. So df is equals to pd.read underscore csv. You know about it, right? So student scores.csv. So this is the csv file, and let's check the head of it. Head of the file of the data frame dev.head. Okay. So now, so once this creation will be done, we'll be starting the next of it, because I need to run this code to see how the data frame looks like. Then only we can continue with it. It is created, then we will continue. And before that, let's rename this notebook also. So right click on it, click on rename, like student analysis. Let's keep a name like this, .ipnb. So yeah, so now it's student underscore analysis.ipnb. So you can see here our things have been created. So here you can see our things have been created, student analysis ipnb file, and here we have the code. So let's run this code. From here we can run the notebook. So let's run this one, let's run this one, let's run this one. Let's see the head of it. Let's check the shape of the data. uh, Shape of the data, that is df.shape. So you can see it's having 25 rows and 2 columns. So I know it's a very small data set, but yeah, we'll be using this one only as of now, because we want to make a faster thing, because I want to showcase to you how to do it using AWS and cloud. So now let's do one thing. Now let's separate x and y here. Separate x and y. That is x equals to df r's, which I want to take it as r's as x, and I want to predict this thing called scores, and this one. So once this thing is done, now what I need to do, we need to convert this one as a float 64 data type, because if you check the data types, checking data types, x dot d type, you can say float 64. If you check for y d types in 64, so I want to convert it into float 64. So let's do one thing, as type float 64. This coming to y equals to, okay, sorry, it would be y equals to, yeah. So now if I check the data type y dot d types is float 64, yeah. So that is done. Now let's use our train test split to split the data into training part and the testing part. So for that I need to import something from sklearn. Same what you have done in your local, you are doing here. Model selection, import train test split, train test split. Yeah, okay, and this is what. Okay, now this is what your train test split looks like. Now let's split the data that is your x train, x test, y train, y test, and let's do it faster. And just skip x comma y comma test size 0.2, and that is done. So now run this one, and now we need to reset the index also. It will throw some error in later, because as we have splitted the data, our indexes will be changed in our data. Like for as if you see the head of it now, you can see 4, 9, 6, 7, 10, right? Indexes are changing. So if you feed this kind of thing in our model, it will throw some error. It will not be able to find the key properly. So what you need to reset the index, and you have to do for everything, for everything what you have done. Like this, Ctrl C, Ctrl V. Now same we need to do it for everyone. Ctrl C, Ctrl V, Ctrl V, Ctrl V, and it would be doing for Y train, Y train, Y train, X test. Okay, Y test. That is Y test. So now, yeah, now it will be working fine. Now what I need to do, two things. First of all, we need to take a label column as vector. So how we'll get it? We need to take a use ilog, train the ilog, all the rows and the first column. Because if you take like this, and if you like to, okay, hold on, all the rows, what is the issue? Hold on, what does it contain? White train. Okay, all the rows. Okay, sorry, it would be 0. I gave, sorry, my bad. Yeah, so it would be 0. I took it by default, sorry, my mistake. So this is what is this thing is here. If you are, I'd like to check off shape of it. Train the shape. So it's 20, right? So it's now one dimensional. So we need to keep it one dimensional, because vectors has to be one dimensional here, the label column. And same will do for this test also. So let's do for test also same. Dot ilog, done. Now let's try to train the model using AWS SageMaker inbuilt algorithm called as linear learner. If I do a Google here, SageMaker linear learner, if I click on it here, this is linear learner algorithm. You can see these linear models are supervised algorithm used solving either classification and the regression problems. For input, you give the model labeled examples x and y. See, x is a high dimensional vector, y is a numeric label. For a binary classification, this must be 0 or 1. For multiples, it must be num classes -1, and for regression, y is a real number. So using this one, we will be implementing our linear learner algorithm. So this is what the documentation, you can go and you can see it, but as of now let's go back to a notebook and let's do it. So first of all, if you're doing the, I need to import certain things, that is import Sagemaker, that is import from Sagemaker, import session. That is one thing is done. So now is this done. Okay, now let's start with the creating the SageMaker session. Let's get the SageMaker session. We need to get the SageMaker session first. SageMaker session. So how can you create it? Dot session. And now we need to define some bucket. We need to define some bucket here. So let's define the bucket name. What is the bucket here? So whatever data we'll be implementing, right, this CSV file, we need to upload it in our S3 bucket. If you don't know what is S3 bucket, let me search it here. S3. So yeah, these are bucket storage system, scalable storage system provided by AWS, where we can store our data. So whatever model will be created, whatever artifacts will be there, and the CSV, everything we need to store it inside S3 bucket, because from there only we send the data in our model. So first of all, I need to create a S3 bucket. To let me create on click on create bucket option, and let me give a name called ytml SageMaker. So I need to copy the name also because I'll use it in the inside the code. So I do not want to touch anything. I just need to create bucket. So it will automatically create your YTML SageMaker, and you can see it also when you search it. You can see it's now empty. Nothing is there inside in it. So now same I need to create. So just define the bucket name. So define the bucket name. Bucket name. So bucket name. Also give it like this. This is our bucket name. Now let me define some prefix here. Define the prefix. What does it mean prefix? Like inside this one, inside this bucket, I want to create a subfolder, and inside the subfolder all things will be stored. So that is called prefix here. So that this prefix I am giving here as linear learner, or yeah, let's give it a linear learner only. Okay, done. Now I need to get the execution role also. Remember, while showing the how to create the SageMaker domain, not the domain but the user part. So there we had a call execution role, right? Same execution role it is also having. So if you want to see it, you can get it. Get the execution role. So if I type get the execution role, and if I click on it like this, key role is equals to SageMaker dot get execution role. So we can see the role also. So once I click on, yeah, I run this one, and now if I click on role, you can see the execution role which was there behind the scene is working. So when I created my user, I selected this execution role, and behind the scene this role is running. Okay, okay. Now our execution role is also being created. Now let's create some buffer, because we will be using the IO module inside Python to create some buffer, because that one only we will be using to send the data in our local to S3, and from S3 will feed into our model. So let's import IO, and NumPy already we have it, and we need to import some common libraries such as import SageMaker, SageMaker dot Amazon dot common import as sysmax. Yep. So run this one. Now let me define it here now. So what I need to do, I need to create the buffer. So create the buffer here. Buffer buff equals to io dot bytes io. Then we need to create a smac dot write numpy to dense tensor. So we need to convert it into numpy to dense tensor. So we will pass here x train and y train. So this is what I passed here, and then I need to set it to 0. So I need to buffer 6 0. You run this one, so we are getting some error. So x has an attribute d type, so I think I need to convert that one to convert numpy array. So x train is equals to x train dot, not dot, sorry, x train dot, I guess, okay, so np dot array. So now you can see I converted into numpy array, and now buffer came up to 0. Now this is done. Now our step would be to upload this buffer. This buffer is containing the data, and now we need to upload the data in our S3 bucket. So what I need to do, for that I need to require another module called OS. So now OS module I have created, and now here let's define the name of the file. So define the name of the file, and define the name of the file, which is, just give it a key as a name. Just give it a student data, student dash data, student data, and now code to upload it, upload in S3. What I need to do, I need to do one thing, use boto 3, which I have imported, dot resource S3 dot bucket. I need to define the bucket name here, the bucket name dot object, os dot path dot join. I guess it should be dot join. So give it a prefix here, the prefix. Then I need to give a name called train. So inside train folder it will be storing, and inside the train folder the file will be stored, the name of the file, that is key, that is your student data. Now I close the another bracket, and I think yes, I click on dot upload underscore file obj, your buffer, the buffer we had here, right? So this buffer will be passing here. So now let me show you the path also, path of our data. So let's keep it like S3 train data. Let me just show you how the path will look like. It is 3 slash like this, train, and then like this. So how things will be done here, first of it will be the bucket name, then it will be the prefix, then it will be the key, and this is where data will be uploaded. Data uploaded, S3 train data, sorry, S3, yes. So data uploaded here. If I go to my, and if I refresh this page, I can see these are linear learner folder, subfolder have been created. Inside the train folder have been created. Inside train folder you can see student data is here, right? So same have been showing here also, you can see same path. Okay. So now data successfully uploaded in our S3 bucket. So now what you need to do, we need to upload, and we need to get the output location also, because we will be requiring some data to upload it also. So let's do one thing, let's set up some output location also. So for that what you need to do is write some code to get it. Now this is what is done. Now let's think about it, because now we need to store the testing data also in the same way, right? Because we did it for the training data, whatever the testing data, same thing we need to repeat for the testing data also. So I am doing the same, so I'm copying pasting the same code again here. So we'll be doing it for test data x test, and then I'm keeping all the code in one place just to make sure things will work fine. And let's keep it as a x test and y test. Now that is done, and let's run this code also here. It will upload our data. Let's keep a name called student data test, and let's change it as a keep it as a test folder, and let's change it as a test folder. So now you can see test data will be uploaded here. If I go back to YTML SageMaker, you can see linear learner. Here you have a test folder. In test folder you have the data test data. Now let's define the output location also, where all the things will be stored here. So so because output will be the model artifacts. Once the model will be trained, it need to store something somewhere. So that also output location you need to define. So let's define the output location also. Output location. Um, Let me define the output location as by myself. Output location is 3, and then this one, and then output. I give it a name called bucket name, and now we'll be storing it like this called prefix, and yeah, prefix. So this will be the output location path. So now let's start the training. So for that, see, whatever this inbuilt algorithm which we'll be using, these all are running on an image, right? So we need to get those images. So for that, what we need to do, we need to search something here. That is, we need to import something. So from SageMaker, so let's do a quick Google search. SageMaker get image URI. So yeah, click on here. Let's find it from documentation. If I go here, or if I go here, you can see Sagemaker image URI is the retrieve. So now you can see this code, right? So this is a newer version where they have written all the things whichever will be requiring. So let's get the image URI from here. Let's see how to import this one. Okay, get image URI. Okay, ठीक है. So okay, of SageMaker dot Amazon dot Amazon estimator import get image URI. So we run this one. So you get the image URI. So now let's bring the container. Bring the container. So for the what you need to do, you need to take the container here. Let's give the name called get image URI. And then what you need to do, we need to pass the region name on the region on which we are working on. So how to pass it? You need to give like boto3 dot session dot region name. So it will give you the region name which is your Mumbai, and the region name will be AP South 1. So it will take it automatically by using this code. So then we will be showing which image we want to use. We want to use a linear learner. So we give the linear learner. We run this one. So it is saying it has been renamed to something else. So let's click on it. Let's click on the docs. Let's see how it renamed. Let's see what was the name they gave here. Okay. So get image URI renamed in Sagemaker greater than 2. So let's search get image URI. Search get image. Yeah, you can find it here, right? So you can see get image URI. That is what they have. Sagemaker dot image URI dot retrieve. Yeah. Okay. Sagemaker dot image URI is dot retrieve. Okay. So we need to do Sagemaker dot image URI dot retrieve. So we're getting some error. Okay, let's see what does it mean. Okay, I think I passed it wrong. I think it would be the reason name. Um, I think I need to pass it here. Control X and Control V. So yeah. So what was the error was it will be continuing first. It will be taking first the framework, which is a linear learner, and then it will take the region name. So I give a region name first, then the framework. That's why it was throwing the error. So you got it right. So this SageMaker image URL is the retrieve linear learner. Go to the session, the region name. So we gave it. So now we have the thing. Now what you need to do, we have to pass the type of instance we want to use while training the model. So let's pass something to work on it. So let's define it. Define the estimator. Define the estimator here. Estimator. So give it a linear sagemaker dot estimator dot estimator. The container, first of all I need to pass. Then I need to pass the role which already I defined. Then the training instance count, how many instances we want. Train instance instance count. Then train instance type. So let's give our train instance type. As of now, let's use this c4.x large. I know it we won't require this much higher instance, but let me show you how to do it. ml dot. So yeah, c4.x large. Then the output path where things will be stored. So output path will be the output location that I have defined above, and then our SageMaker session. This will be the SageMaker session I defined already. So yeah, run this one. So you can see some things have been renamed here. 10 instance count. Let's see what they gave there. So I can go to the documentation. Train instance count. Yeah, so they gave it as an instance count. So let's do it. Intentionally I am not showing you these stuffs because I would like to show you how can we search things from the documentation also. That is why I am using your older codes to showcasing you that how SageMaker is helping us to find it out what we need to give. So this is how you can get it. So this is the instance count. Then let's change it something else, that is instance type. They change it like this, so let's change it like this. Okay, rerun the code. Now all the warning went. So we need to set some hyperparameter now. Setting up the hyperparameter. So let's setting up some hyperparameter also. So that is a linear dot. We need to set up this hyperparameter because we need to tell him key what is the feature dimension. Feature dimension 1. Then the predictor type we need to define predictor type, that is regressor. Then you need to explicitly explain that to the model, and then need to provide the mini batch size. So each epoch, how many batches it will take? It will take 5 batches, for example. Let's say 4 batches, and then let's give a epoch or 5 epochs or 6 epochs, and then let's give the num of models. Num models 32, and then define the loss as absolute loss. Absolute loss. Okay. Yeah. Now let's fit the model. Uh, it will take some time to fit the model. So you can see it here. Linear dot fit. I need to pass a dictionary kind of input here. So dictionary, the key will be the train, and the value will be S3 train data. And I run this code. You can see training job has been started and it will start in the training job. So now you can see training will be started in front of you. So let's wait for some time. So now you can see it's now, I think it's getting some error that unable to execute the algorithm. Provide the train data is in flow 64 format. Float 32 data is required. Please provide 10 data set for 32 and then try again. Okay. So it's requiring for 32 data set. So let's make it for 32 now. And let's do it for same for x also then. X dot s type float 32. So let's run this code again in all cells. So now again it will start the training job. So you can see it's now running the script, and I think training is started. You can see now the maximum minimum model number and all, right? So you can see all the information. Here is a logs. So I think it generally throws a very big log. You can see the log here, really big log. So I think it's almost done. So let it finish the execution. So now training job is completed. Now what we need to do, we need to deploy the model. Deploy the model, because we will be needing the deployed model to do the prediction. First deploy the model. Linear regression like this. Then linear dot deploy. Let's take the initial instance count as 1 because I don't want to pay too much, and I'll be using the instance type email dot import dot x large. But I don't want to host it for too much time, so I will just deploy it, and again I will try to do the prediction. I'll shut it down because it will charge a lot for email.info.x large. So now let me run this one. So now it will take some time to create the endpoint. You'll get some dot dot here in few minutes. You can see now dot dot. So now after some time it will be deployed here. How can you see it? Go to here, your inference, your endpoints. You can see one endpoint kitchen on the way. So this is the endpoint which we can use from local also to do the training prediction, and from Sagemaker also. So as of now we'll be doing from Sagemaker. So let it create first, so then only we can proceed with it. So let it finish it first. So now we can see our endpoint have been deployed. So if you go to endpoint, you can see the endpoint now is in service, and keep in mind it will charging hourly. So I will do it quickly, and I will delete this one because it is charging. So now endpoint is being deployed. So now let's do some prediction on top of it. So for that I need to import certain things again. So let's go up, um, Sagemaker dot predictor import CSV, uh, um so let me import it here. So you can see here in the documentation, I'm just checking the name because they have changed it something else. So from Sagemaker dot predictors, okay, that serializers, right? Okay. Okay, let's do one thing. Let's not import like this way. Let's do one thing. Let's not import it like this way. Let's do one thing. Let's come here and let's do it like this. Linear regressor dot serializer serializer. Okay, let's do it like this. So one copy. And let's do for same. Dot the serializer. Let's do it like this. Let's take the CSV serializer and JSON deserializer. These both will be recurring here, and if I run this code, it should work. So I think okay, the name is different. So let's do it like this. You can see it already took it. Now, for example, if I want to do the prediction on the data, so now it's prediction. Let's do the prediction. So if I want to do the prediction on the data, that is result is equals to regression dot predict. Now let's pass the test data. So if you want to see the results, you can see we are getting the results. So now get the predictions. It's coming as a dictionary format. So let's get it properly by running some code. So let's do it for our for our results. Let's take the uh, predictions. I the score. Let's make it an numpy array. So look at the predictions here. Present score predictions. So you are getting all the predictions here, right? So this is what we have done the prediction. Now let's check that how test data have been, like how model have been fit here. So this is what I would like to showcase to you. This is a very basic implementation I have shown how we can do it using Amazon Sagemaker inbuilt linear learner algorithm. So you can see now endpoint is on deployed also, and using that deployed endpoint we have done the prediction. So in later video I will come with the more Sagemaker contents. So the last step, let's delete the endpoint also because it is charging for me. So let me just delete the endpoint also. How to delete it? Let's do linear regression dot delete endpoint. So if I run this one, so you can see if I refresh it, see no instance, no resources here. So the endpoint have been deleted. So that's all for today's video, guys. If you want to get the notebook link, go in the check description box. I have provided my GitHub link. So guys, thanks for watching this video. Bye.